In this video, I will be explaining you the converse part of Tutte's theorem. So here you are assuming this and you are going to prove G has a perfect matching M. Okay. So in this proof at the end, you are going to bring the contradiction. That kind of proof you are going to write. So for that you are writing, suppose G has no perfect matching. If G has no perfect matching, then you are considering another one graph, that is G star, and this G star is a maximal graph. Okay, and this maximal graph is having no perfect matching. That is how you are taking a graph G star. Now you are saying that if G star is the maximal graph having no perfect matching, then this G will have this G is a spanning subgraph of this G star, because this G star is a maximal graph having no perfect matching. G is also having no perfect matching. So both are having no perfect matching, but in these two graphs, this is the maximal graph. So that is why you are saying from these two lines you can say this G is the spanning subgraph of this G star. Okay, and in the next line what you are doing is, since if G is a spanning subgraph of G star, means even when you find G minus S, that G minus S will also the spanning subgraph of G star minus S. Okay, so that is what you are writing. From this line only you are writing this, but you have to understand, if G is a spanning subgraph of G star, means even when you find G minus S, that will be the spanning subgraph of G star minus S. Okay, that is what you are writing. Now in the next line what you are doing is, we have number of odd components of G star minus S will be less than or equal to number of odd components of G minus S. How you wrote this? I will tell you how. Okay, so here we have to understand something, that here G minus S is a spanning subgraph of G star minus S. Is that clear? So from this line you are writing this. That is, this G minus S is a spanning subgraph. You know what is spanning subgraph, right? Spanning subgraph means when you remove any of the edges from that graph will become disconnected, and the possibility of more number of components is high when comparing to this. Okay, when comparing with this graph. So that is why this is spanning subgraph. No, so even if you are removing one edge, there is a possibility of getting more components of the graph is high. That is why you are writing the number of odd components of G minus S will be greater than number of odd components of G star minus S. The reason is because G minus S is the spanning subgraph. Okay, and so by assumption we get, and from assumption you are writing, now assumption what we have, order of G minus S less than or equal to mod S, right? So here in the place of order of G minus S, you are substituting that, so that in the next line you will get order of G star minus S less than or equal to modulus of S. For all this S belongs to vertices of G star. Here you have G, so that is G, that is why you are writing S subset of S contained in V. Here you are writing for G star, that is why to show the difference you are writing. In this case, this S belongs to vertices of this G star. Okay, so only from the assumption you are writing this, just mark it as equation number star. Now in particular what you are doing is, you are setting S equal to empty. That is, you are giving the value of S as empty, means the value is 0. Okay, empty. no elements are inside the set, yes. Okay, so that is how you are setting. So if you set like that, what will happen is from this step you are getting this. If s equal to empty means when you find the number of odd components of in this equation, you are putting in the place of s, you are putting you will get 0. Okay, because you have s equal to empty. So here also in the place of number of vertices in s becomes 0 because there is no vertices. Why? Because s equal to empty, that is how you set, right? So from this you are writing order of g star equal to 0. And so if a number of odd components of g star is 0 means the vertices in g star will be even, right? Because there is no odd components. That is what you come to know. Order of g star equal to 0. It means there is no odd components in g star, right? If there is no odd components means what? The vertices present there will be even, right? That is what you are writing. And then what you are doing is you are considering a set of vertices, and that vertices will have degree v minus 1 in the graph g star. That kind of vertices you are choosing, and you are naming that kind of vertices as capital letter U. Let U be the set of all vertices of degree v minus 1 in G star. Here, since G star clearly has a perfect matching if U equal to V. If this U, set of all vertices of degree v minus 1 in G star, this U is equal to V, then G star will clearly it will be a perfect matching. If U equal to V, then G star will be the perfect matching. Okay, that is how you are writing. And the next line what you are doing is you are assuming U not equal to 0. This U not equal to 0 means you have to claim G star minus U is the disjoint union of complete graphs. Oh my god, what a huge proof. I feel very tired. We assume U not equal to V. So we have to climb G star, but we have to study, right? This theorem is very, very important theorem. This is one of the most expected named theorem in this unit. Okay, from this unit for 8-mark question, this question is most expecting question. So we have to study. Okay, at any cost we have to study, right? So that is why I'm trying hard to make that possible. To learning this theorem is very important, right? Claim G star minus U is a disjoint union of complete graphs. We have to prove G star. We know that what is G star? G star is the maximal graph having no perfect matching. Here you have wrote like that. So from G star you are subtracting this set of all vertices of degree v minus 1 in G star. So you get G star minus U graph, and you have to prove this G star minus U graph is disjoint. It means this graph having different components, and that components and different components, and it is the union of complete graph. That is how you are going to prove. G star minus U is the disjoint, and it is the union of complete graphs. That is what we have to prove. Let's see how we are going to prove that. Okay, let me do something. We can see that in another video, because this video is very lengthy. It takes too much of time to upload on YouTube. So I will upload the remaining part of this video in another video.